Hi everyone, this is going to be part 2, which is type 2 ionic. I'm assuming in this video you're comfortable with how to name type 1 ionic, so I'm not going to go into as much of the background about like metals and nonmetals and the charges and 1A, 2A, 3A and so on. So if you do need to brush up on that, go back to that first video. So type 2 ionic compounds. What are type 2 ionic compounds? Well, they are ionic compounds in which the metal is a transition metal that can have a variable charge. Many of the metals in the middle of the periodic table, dozens of them, can change their charges, can sometimes have a +2, sometimes a +3, sometimes a +1, sometimes a plus whatever. They're always positive though. They can never be negative. All metals have to give away electrons. They can never accept them. But they can have variable charges. So we can't name these the same way. And let me just give an example here. Let's say we have... just one more thing I want to clarify. The transition metals, it forms this block here in the middle. And a lot of like textbooks just call it that block. But it also extends in this triangle down here as well. And that's important because, for example, Pb is lead, Sn is tin. Those are two very common transition metals. Even though lead and tin are both in group 4A, they don't always have 4 valence electrons and give away 4. They are considered transition metals. They do not bond similar to carbon and silicon. Even the ones below it here, like indium and thallium, they don't exactly behave like the ones at the top, so these are going to be transition metals as well. Even bismuth down here can, it's rare, but it can act as a transition metal as well. So the transition metals, it's this rectangle plus this triangle down here. So please, if you see Sn or Pb, don't say, oh, that's in group 4A, it must form a 4+ charge. No, not always. Sometimes, but not always. So anyway, here's an example of why we have to name it differently. We can't just use the same old naming convention. Imagine we have cobalt, which is a transition metal, Co, and let's say we have cobalt bonded to fluorine. All right? So let's say cobalt exists in two forms, CO2+ and CO3+. Well, let's say we were going to bond each of these with fluorine. Well, fluorine is F-. With the nonmetals, the anions, cation's a positive, anion's a negative. With the anions, there's never any question about the charge. It's always consistent. So when you bond these together, you crisscross them and you're going to get COF2. And when you bond these together, you crisscross them and you're going to get COF3. Now, according to the type 1 naming rules, you don't care about the number. You would just say cobalt fluoride. Cobalt fluoride. See where the problem is? These are two separate compounds. These are different compounds which could have very different properties. They can't share the same name. So when it comes to type 2, whenever it's a transition metal that can have multiple charges, you can't just say metal, cobalt fluoride. You have to change it. And the rule we use for this is Roman numerals. The Roman numeral is going to indicate the charge on the metal. Again, it's the charge on or of, the charge of this metal. It is not the number of things attached to it. This is a common misconception. The way I made this, it happens to work out that way, but I'll go through another example where it doesn't. So again, we're going to call this one cobalt 2 fluoride, and you put the 2 in Roman numerals. So when you're saying it just out loud, you would just say cobalt 2 fluoride, and this one, because it's 3+, is cobalt 3 fluoride. So the charge of the metal gets stated in between the two. Cobalt 2 fluoride, cobalt 3 fluoride. When you write it out, you say cobalt, parentheses, Roman numeral 2, close parentheses, fluoride. Fluoride, of course, F-L-U-O, not O-U. So cobalt 2 fluoride, and this one is going to be cobalt, Roman numeral 3 fluoride. So that's what they look like when they're written. Now when you speak these, when you read them, you don't say cobalt parentheses 2 close parentheses fluoride. You just say cobalt 2 fluoride, cobalt 3 fluoride. Okay? And again, very common mistake people make is they say, oh, cobalt 2 fluoride. That means there's 2 fluorines, so it's going to be COF2. Cobalt 3 fluoride, that means there's 3 fluorines. It's going to be COF3. That's not what it means. It happens to work out that way, and technically it's anytime the anion has a 1 minus charge, it's going to work out that way. But it's just a coincidence in this case. Here's what I mean. Let's say the same two compounds, the same two cobalt ions, CO2 plus and CO3 plus, are now going to bond with oxygen. Oxygen is always 2 minus. Okay. What's the formula going to be here? Well, it's 2 plus and 2 minus. They balance out. It's going to be COO. Or if you crisscross it, you can do that, but then you have to simplify it. So CO2O2 becomes COO. And make sure you're careful about how you write that. It's capital C, lowercase o, capital O. This one down here is going to be a 3 and a 2. You crisscross them, and it's going to be CO2O3. Now this one is going to be called cobalt 2 oxide, and this is going to be called cobalt 3 oxide. Notice that whole thing about the number of things attached to it doesn't work now. So it's not the number of things attached to it. It's the charge of the metal. Okay? So when it comes to writing the formula for these, it's very simple. Like if I'm going to backtrack from here, actually let me write these out and we'll backtrack from here. Cobalt 2 oxide and cobalt, I don't need parentheses there, whoops. Cobalt 3 oxide. Okay, so let's see. Imagine I gave you just the name, cobalt 2 oxide. Let me erase this. Cobalt 2 oxide. And you wanted to find what the formula is going to be. Well, you first write down the ions. Again, I said this in my last video, I'll say it again. When you're writing the compound down, the formula of an ionic compound, write the ions out with their charges, then write them as, like, crisscross them and then write the formula. Don't try to do it all in your head and then just put the final answer down because you'll make a lot more mistakes. So cobalt 2 oxide. Well, cobalt is CO and oxide is O. Oxide is always 2 minus, no question about that. Cobalt is a transition metal. Looking at the periodic table is not going to help us. I mean, you could look there to get the name, but this helps me with nothing because it doesn't tell you what the charge is. So how do we know what the charge is? That's what the parentheses are. So when you see cobalt 2 oxide, that 2 means that this particular cobalt is 2 plus, and now we can finish it out, COO. What I can't do is this. I can't say, write the formula for cobalt oxide. If you do this, bring it to your teacher and say, I think you made a mistake here. Okay? Cobalt oxide, there's no way of knowing. You would have to guess what the charge is, so it doesn't make sense. So again, I think it's very simple to go this way. When I give you the name, you just write the symbol out, CO, with this Roman numeral as its charge, and then you write the second part, you crisscross it. Let's see how we would go the opposite way. What if I just gave you that and said, what's the formula? Now, you might have it memorized from before, but let's pretend this is a fresh example. Sorry, when I said formula, I meant name. So what's the name of this going to be? Well, you can't just say cobalt oxide because it's a type 2. And you know it's type 2 because cobalt is a transition metal. It's not one of the type 1s. So you can't just say cobalt oxide. What we have to figure out is what's the charge of this cobalt. Okay? So here's what I suggest you do with this, especially when it's a 2 and a 3. It's a little tricky. I mean, some of the easier ones you can kind of figure it out in your head. But here's what I would do. The positive side of this is the cobalt. Okay? We have 2 of them. CO2. Cobalt, cobalt. The negative side is 3 oxygens. Oxygen, oxygen, oxygen. Okay. What's the overall charge of this compound? 0. It balances out. That's the whole point of an ionic compound. So all the positives on this side balance all the negatives on this side. Well, what's oxygen's charge? Because we don't know cobalt. We never know what it is. And when I write it like this, it doesn't tell you. That's the whole point. We need to figure it out. It's like a puzzle. We don't know cobalt, but we do know oxygen. What's oxygen's charge? 2 minus. So we have 2 cobalts that are able to cancel out 3 oxygens. Notice the charges. What must the charge on each of these be? 2, 2, 2, that's 6, 2 here, so it's got to be 3 plus. So the answer for this is going to be cobalt 3 oxide. Okay, cobalt 3 oxide. It's not going to be cobalt 6 oxide. That's another common thing where people will say, well, look, there's 3 oxygens, that's a total of 6. So what's the charge of the metal? The metal must be 6 plus. No, we need the charge of each of these cobalt ions. So each of these is a 3 plus. And when you're first starting out with these, a good way to check it is this. We started with this, and we got this as our answer. Let's cover up the work and work backwards and see if we get the same answer. Well, cobalt 3 gives you CO with a 3 plus charge. Oxide is O with a 2 minus charge. Crisscross the 3 and the 2, you get this. Let's say you accidentally said cobalt 6 oxide. Let me erase this. Let's say you accidentally wrote cobalt 6, which is Vi. I should clarify in a sec what the Roman numerals are. Cobalt 6 oxide. Okay? What you should do is check it. Now to check it, you write the compound out. Cobalt is CO, and this particular cobalt would have a 6 plus charge. Oxide is O with a 2 minus charge. What's this formula going to be? Well, I would just look at it and say 6 plus 2 minus. You need 3 of these. So it's going to end up being COO3. If you want to crisscross it, that's fine, but because these are both even numbers, you can simplify it. You have to simplify it. So this would be CO2O6, which then has to become COO3. Notice, COO3, not the same as what we got. So hopefully you'll catch that mistake there. All right, so that's how you figure out the name and the formula. Here's some practice problems. Two things I want to get at. First, Roman numerals. You should know 1 through 10. And if you haven't learned them in school, it's 1 is that, 2 is that, 3 is that. Now sometimes you can put the little lines above them like this. I sometimes do, sometimes don't. I'm not very consistent. Now for 4, you don't say I. You do IV, because a V is 5. And to show 4, you do the 1 before the V, meaning it's 1 less. So it's IV, and 5 is V. And again, you can either leave them like this, or you can put the lines going across the top. So that's 1 through 5. For 6, you do VI. For 7, you do VII. For 8, you do VIII. Now, for 8, you could say, hey, hold on, can't you like save letters by saying IIX? You would save letters, but that's just not how you do it. You're not allowed to have more than one thing less, I think, at least at these low numbers. So 8 is VIII, it's not IIX. 9 is IX, and 10 is X. So again, you can either have them like this, or you can put your lines above and below. Those are Roman numerals. You should know 1 through 10. It's good to know in life, Super Bowls and whatnot. Okay. Second thing I want to mention before we do is some practice problems. Which cations are considered type 1? I pulled this right from my last video. If you ever see these, they are not type 2, and you are wrong if you use the type 2 naming for them. So don't think that you're always going to use Roman numerals. The type 1 cations are the ones that always have a known charge. On your periodic table, that means group 1 metals, group 2 metals, and the 3-2-1 metals, aluminum, zinc, silver, and ammonium, which is one of the most common polyatomic cations. Okay? So if you have any of these, you're wrong if you call it type 2. So for example, if you have NaCl, you're not going to call that sodium 1 chloride, because sodium is always 1. If you have aluminum bonded with sulfur, you're not going to call it aluminum 3 sulfide, you're just going to call it aluminum sulfide. So make sure you're able to distinguish between type 1, which are when we know the charge, and type 2, which is these transition metals when we don't know the charge. Okay, so here's some formulas. Your job is to find the to write out the name. If you want to pause here and then play it again, you can do that. So, first of all, I know that this is type 2 because mercury, Hg, is not one of those type 1 metals. It can have multiple charges. So we have to figure out what the charge on this particular mercury is. So I like to kind of break it down like this. I have a mercury on the positive side, and I have 2 oxygens on the negative side. Well, I don't know mercury, but I do know oxygen, and oxygen is always 2 minus. So what must that mercury's charge be to balance it out? Well, it must be 4 plus. So because that mercury must have a charge of 4 plus in order to be balanced, this is going to be mercury 4 oxide. For this one, chromium with 3 chlorines. So we have to figure out the charge on the chromium in order to name this. So I have 1 chromium on my positive side. I have 3 chlorines on my negative side, and these must balance out. So each chlorine is minus, giving me a total of 3 minus. I have 1 chromium that's able to cancel that, which means that chromium must be 3 plus. So because it's chromium 3 plus, I'm going to call this chromium, Roman numeral 3, chloride. Pb2S3. Pb is lead. And just to drive this point home here, lead is in group 4A or 14. That does not mean it always has 4 valence electrons and always gives up 4 or takes in 4. Now metals never take in valence electrons, but it's not going to always be plus 4. Same with tin, Sn above it. These are transition metals. They can have many different charges. So let's figure out what this lead's charge is. Well, again, I'm going to use my trusty method here. I have, on the positive side, I have 2 leads, Pb, Pb. On the negative side, I have 3 sulfurs. I don't know lead's charge, but I do know sulfur's charge. Sulfur is 2 minus. So what must each of those lead charges be in order for this to work out? Well, 2, 4, 6. I have 2 of these, so it must be 3 plus and 3 plus. So because I have a lead with a 3 plus charge, I know my answer for this is going to be lead, Roman numeral 3, sulfide. And when you speak that, you just say lead 3 sulfide. All right, last one. V is vanadium with a 3 vanadiums and 1 nitrogen. So I have vanadium on the positive side, 3 vanadiums, and 1 nitrogen on the negative side. All right, well, I don't know vanadium's charge, but I do know nitrogen. It's 3 minus. So what must each of those V's be? Well, they must be plus. That's the only way it works. So this one is going to be vanadium 1 nitride. Nitride. Not to be confused with nitrate or nitrite, which are on your polyatomic ions list. Nitrate and nitrite are 2 pretty common polyatomic ions. Nitride is just regular N. Okay. Here's a few more examples. I'm going to run through these a little faster. I'm maybe not going to use my breakdown method for all of them. So MnBr2. I don't know manganese, but I know bromine. I know that bromine is -1, so this manganese must be +2 in order for it to cancel out the 2 bromines, giving me manganese 2 bromide. Mn, not to be confused with Mg. Manganese is Mn, transition metal. Magnesium is Mg, not transition metal. That would be type 1. If that were MgBr2, you would just say magnesium bromide. Zr2O. I don't know zirconium's charge, but I do know oxygen's charge, which is 2 minus. Well, if I have 2 zirconiums that balance out 1 oxygen, each of those zirconiums must have a charge of 1 plus. So this is going to be zirconium 1 oxide. Oh, and don't know if this came up before. Looks like it did. When the charge on the transition metal is a 1, yes, you have to include it. It's not like, and a lot of times when there's a 1, we don't write a 1, like for example here. But in this case, when the charge is 1 plus, you have to write 1. You can't leave it blank. SN, SE. Sn is tin, just like lead. It's right below, above lead. It's not always a 4 plus 4 minus, or it would never be 4 minus. It's a transition metal. So Se is selenium, which is 2 minus. So that tin must be 2 plus. Simple as that. Tin 2 selenide. Ti2S3. This one I'm probably going to write my little grid out because it's a little complicated. So on the positive side, I have 2 titaniums, and on the negative side, I have 3 sulfurs. Well, I don't know titanium's charge, but I do know sulfur's charge, which is 2 minus. So what must titanium's charge be in order for this to work? Well, it must be 3 plus, because here I have minus 6 and plus 6, which gives me a final answer here of titanium 3 sulfide. Okay, so that's how we name these. Let's do it the other way. In my opinion, it's a little easier to do it this way, a little quicker at least. So again, when you're writing formulas for ionic compounds, please get in the habit of writing the ions with charges, then getting your final answer. Don't just look at it and say, here's my final answer, because you'll make a lot more mistakes. Chromium 2 oxide. So chromium is Cr, oxide is O. I know oxide is always O2 minus. I don't know chromium's charge by looking at the periodic table. No matter how hard I scour this paper, it's not going to help me. Where do I get my charge? Right there. That 2 means that this chromium has a charge of 2 plus. And now that I know that, I can see it's going to be CrO because it's 2 to 2. You cross it and then simplify it. Again, common mistake that I see a lot is people see chromium 2 oxide and they very quickly write this. CrO2, because there's 2 of them. That is not correct. Okay? The Roman numeral does not mean the number of anions. It means the charge of the metal. So again, this one is going to be CrO. Copper 1 phosphide, that's copper with a plus charge. Phosphide is P3 minus. You crisscross them. Cu3P. Copper 1 phosphide. Iron 3 selenide. So iron is Fe, and the 3 means it's a 3 plus. Selenide is selenium, Se with a 2 minus. You crisscross those, you get Fe2Se3. Gold 5 bromide. Gold is Au, and V is 5, so it's a 5 plus. Bromide is Br minus. You can crisscross them and see that we're going to need Au, Br5. Manganese, not to be confused with magnesium. Manganese 3 nitride. So manganese 3 means Mn with a 3 plus charge. Nitride is N with a 3 minus charge. And hopefully you can see right away that's going to balance out, giving you MnN. If you crisscross it, Mn3N3, you have to simplify that down. If you write your answer as Mn3N3, it's wrong. MnN. Exactly like that. Capital, lowercase, capital. Finally, cobalt 1 sulfide. So cobalt 1 is Co with a plus charge. Sulfide is S with a 2 minus. You crisscross them, and you're going to end up getting CO2S, just like that. Okay? All right. Good luck with your type 2 ionics.